OSPF areas in general have a wide variety of uses beyond just scaling. Let's deploy a stub area and perform some fancy filtering to implement a traffic engineering scheme. R13 is a router connected to R10 and R11 that will serve as a BGP route reflector later in the course, and our goal is to isolate it from the rest of the network. I've placed all its interfaces in Area 3, making it an internal router by title. However, Area 3 is a special kind of area, and we can check the global OSPF configuration to learn more. I've configured it as a stub area, meaning that no external routing information, such as LSA types 4 or 5, may exist within this area. The ABRs R10 and R11 both originate default routes into the stub area to ensure internal routers like R13 have reachability to external destinations. If you want to verify the behavior of any special area type without inspecting the configuration, you can check the global OSPF settings. As seen in the previous course, the end of this command prints a summary of each area configured on the router. R13 reports that it has 3 interfaces in Area 3, one of which is a loopback, and that it is a stub area. Let's head to R10 to review its global OSPF configuration next. It's almost identical to R13 except has the word no summary after the Area 3 stub declaration. Sometimes you'll hear this called a totally stubby area, but I dislike that term because it implies a different type of area. This command simply filters all LSA3 generation into Area 3 on R10. Area 3 is still a stub area, and this setting is not signaled in the OSPF hellos. This option causes R10 to only originate an inter-area default route into Area 3. To prove it, we'll display the self-originated summary LSAs within the Area 3 LSDB. There's only one entry, and it has a link ID of 0.0.0.0 with a network mask of /0 indicating a default route. The default route cost is set to 1, but this can be overridden. Let's head to R11, the other ABR, to check its configuration as well. R11's setup is a bit more complex. First, notice that it isn't using the no summary keyword, indicating that R11 can originate non-default summary LSAs into Area 3. I've also overridden the cost of the default route to 500. Last, I've applied a prefix filter matching all loopbacks in the range of 10.0.0.0/24. This limits the inter-area prefixes advertised into Area 3 from other areas. Given this configuration compared to R10, what do you think the traffic pattern looks like from R13's perspective towards different destinations? Pause the video and give yourself a few minutes to articulate your thoughts. We'll verify this on R13 shortly, but here's what I think is going to happen. R11 will be the preferred egress point for all loopbacks in the network because R13 should have exact matches for those destinations. R10 is only originating a low-cost default route, so R10 will be the preferred egress point for all non-loopback traffic. If either router fails, the other device will be able to provide full reachability to all destinations. Let's head to R13 to ensure that my hypothesis is correct. First, let's confirm that R13 sees both ABRs using the show IP OSPF border routers command. The output indicates that we have intra-area paths to both R10 and R11, each with a cost of 10. R13 sees these devices as ABRs reachable via Area 3, which is correct. Each device is originating a default route, so let's confirm R13 has learned both. We'll query the LSDB for any Type 3 LSAs with a link ID of 0.0.0.0, then extract the advertising router ID and metric value. The primary path through R10 has a cost of 1, while the backup path through R11 has a cost of 500. If we check the routing table for the default route, we should see R10 as the next hop. Additionally, we should see a handful of loopback prefixes with a next hop of R11, which is the result of omitting the no summary keyword combined with a prefix filter. At the top, we confirm that the default traffic routes through R10 with a cost of 11, computed by adding the Type 3 LSA cost of 1 to the link cost of 10. The remaining routes are loopback prefixes reachable through R11 as we suspected. To quickly test it, I'll traceroute to 2 IPs on R10. First, I'll target the transit link between R10 and R11, which should follow the default route through R10. R13 followed the default route through R10 to reach this destination as expected. Next, let's try R10's loopback, which should take a different path. Because R11 injected longer matches for the loopbacks, R13 prefers R11 as an egress point from Area 3 towards these destinations. The point of this clip was to illustrate that OSPF areas, and stub areas in particular, are useful for more than just scaling and flood isolation. A mix of summarization and filtering can create highly optimized forwarding paths based on your business needs.